Hi, my name is Adrian. We're gonna continue our tutorial making an equalizer with Krakatoa and particle flow in 3ds Max. So this is the scene where we left off. Basically we applied the second technique and we have one frequency animation. So let's see what you have now. So this is the animation. Okay, next we see that we have a little issue. We have a parent visible. So in order to fix this, we are gonna go to PRT loader, select our file and disable in viewport and render. Go to particle view by pressing 6, enable it by pressing this icon, light bulb. So we have our animation back. Go to frame 15 and we want to re-export this frame. Let's go to render setup, go to render tab, open Krakatoa graphic user interface and change this to save particle to file sequence, and I'll select just one frame 15, and what we need to do now in order to not render the parent particles, we can see that Krakatoa is set up so it will render the pflow geometry, pflow phantom, and not render pflow bounding box. You can also disable pflow phantom if you want, but we'll use bounding box. So let's open particle view, we want the parent to render as bounding box, so go to render operator and change it to bounding box, and the generated particles to be rendered as normal geometry. So let's drop on render operator here in event 2 like so and leave it to geometry. And now press save particles. Yes. Yes. Okay. So now change it back to render scene particles. You can change it to range or active time segment. So we can make previews. Close this. And when we will render now, sorry, we need to disable particle flow, so and re-enable the PRT loader. Let's see if we don't need to reload it. Second. Okay, it's loaded automatic. We see that we don't have the parent particle visible anymore. So let's close this. What do we want to do next? First, let me show you that you can use the same shape. You can duplicate it, for example, like so. Let me enable angle snap, like so. Also, if your viewport is getting slow, you can set this to load every end particle, like so, and change the percent to something smaller, like 10 or 1. Okay. So now, sorry, this is the rendering setting. 100%. But with viewport, we want to use every end particle. Sorry. And change it to 10%, like so. 1. Let's see. So now we have the same animation in 2 directions. Almost good. Let's position this better. So okay, so this is the same, exactly the same animation, so we can make it one more, doesn't matter. We now are rendering in point mode, so depending on what distance we are, the density of the points will vary. So if you can change it to voxel rendering if you want to have more stable density, so like, well, you can see the same density, but we'll use particles for now. Okay, so what if, for example, we want to assign a different frequency to one of those? Go select one, open Magma editor, input object, and select we don't have, we need to create them, so let's do this. Let's see. So we have now this motion. It's using the help position, so pose help position. I didn't try it, but it should work. Let's try to bind it with variable, so it will be dependent on this node. So Max will know about this, and when we'll duplicate it, it will maintain the hierarchy. So let's try it. Helper. Let's create a new variable named helper. Create. Assign to node. Let's see. We want the point help. Pose help. Pose help. Okay. So now if we change this to, let's copy this just in case. So it's still working, but now it has a dependency, hierarchy dependency on each one. So now you see that assigned to pose help. So now if we will duplicate this, let's see, make a test render to see if everything is working okay. Yeah, okay. You can press also end render, see the animation. Maybe if you want to offset it a little bit, but we'll do this later. The offset is I'm talking about is this. Let's remove this node, we don't need this. This 15, so we can offset it to start at a to have a smaller evolution. Okay, so let's duplicate this those on for the next frequency, like so. Copy. So now if we'll select sound driver 001, and if we'll go to motion panel position, Z position, we should see that the helper is now okay, it's renamed. Okay, we see that everything changed. 001. Okay, so now to change the frequency, you can change also the color to see that this is another one, and go to sound provider, go to position, Z position, double click, and change the sound. We'll change this to, for example, low frequency 16-bit. Okay, close. Now let's set this one to be based on low frequencies. So open Magma, input object and sound driver, click here, press H, and the sound driver 001. we'll rename it soon. Date, just to be sure it's set to auto update, but just in case. Close this. And now, yes, you see that it has a different offset. Let's see what we have now. You see a different response. Also, we can change the material. No, actually we've exported the colors, but we can make some offsets in colors if you want. I didn't export VOV. If I've exported VOV, I could maybe it's a better idea to export the UV channel by exporting it here. So let's do this. Let's experiment a little bit. So save particles, and let's also export the texture coordinates like so. And now change this to save particles, one frame 50, like so, and disable all of those like so, like so. Enable particle flow, and let's render just one frame here. So save particles, yes, yes, okay. Change it back, render, active time range, close, minimize, disable, and go to each one of those and enable it back. Render viewport, render viewport, the last one. Right, this is enabled. Where is the last one? Okay, like so. Now, by having the texture coordinates, we can make something interesting here. So let's change the color of the particles. So to do this, we'll create a new output node, set it to color, like so. We'll add an input texture map, like so. Let's press M, like so, and we're gonna duplicate this map instance. Let's make another duplicate, so we can work on first instance, and we'll name the second one second map. Doesn't matter, just to make a duplicate. So this will be map 2, this will be second map. So let's change the colors, like green and maybe I know red. Not so beautiful, but that's yellow, red. Okay. Also we can of course add another submap instead of a color to have more variation. Let's add another noise, like so. Change this to maybe green, so, and this to yellow. Big contrast, like so. 0.6, 0.5, smaller, maybe 5, 10. Okay, so this should work. And let's see. So this the second map, add texture map, and go to scene material, second map. Okay, instance. And now we want to plug this into the colors. So let's see. We see that this one has. Okay, so let's see. Let's render. Yes. So if you change the frequency, you may also need to change the offsets and multiplier in Magma Flow. So I don't like that it's too dense. Let's go to Krakatoa, density, and set this to 1. Let's see what we have now. Okay, looks much better. Render. Yes. Okay, now we're gonna make some interesting endings. Right now it's fixed ending, so it's linear, but we want some randomization. Okay, so this is one technique how you can make our lines, but also you can re-export our particle. You can go on particle flow and change, for example, the shape, and export another particle sequence, and use that for PRT loader, like load it here. So I think you'll figure it out, but let me show you just in case. Hide selection, particle flow. So we can modify the existing path, but it's not a good idea, because you can, if you want to go back and make some changes to the first path, may not be such a good idea. So let's instead duplicate it. Draw another line. So okay, so now we're gonna go to frame 0, duplicate this, copy, and I'll use the same particle source, but if you want you can create another one. The minus of using it like this is that you need to disable the one that you don't want to render. So let's select the second particle speed icon, speed back and true, change the position constraint, path constraint, sorry, to, I don't like that it's getting offsetted. Show and track view, it should be 0, like so. Here 100. Okay, close, and yes, let's delete path, add path, and add the second one. Don't forget to uncheck this. Okay, so it's now using the second path. Also we want everything's okay. So let's export this one, F10, come on, single frame, frame 15, or you can set this to frames 15, like so. And let's go to Krakatoa, save, texture coordinates, okay, and let's change the name to strand 2, and let's save. Okay, everything is good. Now change it back to render, come on, active time segment, close, 6, disable this, unhide all, and let's change this to strand to remove. Yes, add files, strand to. Okay, so let's rotate it like so. So if we'll now render, yes. Also, you can change the emission plane to something else, like a cylinder, sphere, and rotate it. It's use your imagination. Okay, now let's hide everything. We'll gonna make the random endings, squarish endings. So hide selection. Select those two, hide selection, press 6, and we'll use the first event for now. Enable, so we have back our particles. So in order to do that animation, we're gonna do the next thing. Particle flow. We're gonna test spawn by travel distance. We're gonna test that our particle age. So age test, and if it's our path follow animation is 30 frames, so you're gonna set this to 30 and variation of 0. And change it to is greater than test value. So if our parents are greater than test value, which we're gonna do, we'll create another event. Let's drop on data test data operator like so. Let me maximize this. And set this here like so. Connect this to age test like so. So dive in data operator. Do not check auto update for now. So let's how it will work. It will change the particle direction at random intervals into rectangular direction, so 1 0 0 0 1 0 0 0 1 and inverse, like -1 0 0 and so on. So to do this there are many techniques, but I'll use a simple one. We'll create 6 vectors, so you have 3 axes and 2 positive and negative for each axis. Let's create 1, Ctrl C, Ctrl V, 2, Ctrl V, 3, Ctrl V, 4, Ctrl V. Let's put it here, 5 and 6. Okay, so first one will be 1 0 0, the second one will be 0 1 0, the next one will be on Z direction, the one below will be negative, so 0 -1, 0 -1. Okay, so now we'll want to use a pipe to a pipe is like a switch. We'll use in this case we have a switch also, but it's working a little different. Pipe is letting the flow walking through it with also condition, pipe condition. See, switch will only have conditions. So let's remove this. Let's set the data type to vector, valve type to integer, because we want to select index like so, and we'll use from 1 and up, so 1. Remove all. I want to set the exact match. 1, 2, 3, 4, 5. So we have now 6 inputs. 1, 2, 3, 4, 5, 6 vector inputs and 1 switch input. So for this switch input, we'll use a uniform, random uniform. So let's set this to integer and uniform discrete. So we'll set this 1 to 6. You can set it to 0 to 5 also, because the 7 input will be for all our values. So whether it will be 0 or 6, doesn't matter. Let's connect this to integer. Let's see if we need to change another value. No. Okay, so let's now pipe in all those vectors. Doesn't matter the order, because it's random, like so. Okay, now we want to change only the directions, so we want to keep the speed. So let's set input standard and set it to speed magnitude. Okay, so now we also want to use a function, and we'll use the first operator will be a vector, the second one will be real. So the real will be speed magnitude, like so, and the vector will be the output from pipe. Okay, now this will be our new velocity output. So let's set to output standard. We want speed vector and set this to vector like so, but we want not to change at each frame or each time step, but we want to change it at random events. So for this we'll use another random operator like so. It will be a Gaussian from 0 to 1, and we want to put a condition. So condition like so. So if our input is less than a threshold like 0.3, change the speed vector, like so, velocity or direction in our case, because we keep the speed. So now let's close this, update, and you can turn now auto update, and let's see what we have now. Let me close all of this. You see, now they are randomly distributed in space, walking in squarish type, but they don't let any trails, so we'll use the same thing. So as previous setup. So let's move this in this direction by dragging this output, and so we'll wanna now make the same spawn here to leave the particle trails, and we'll not don't make a copy, for instance, because particle flow will crash. Instead, sorry, let's drag this H test before spawn, so will not affect any spawn particles, even if it's set to go to this event, to avoid some problems, crashes, so on. And let's put here a spawn operator, like so, by travel distance 0.5, step size same as here. So restart particle H, like so, divergence 0, and before scrolling timeline, make sure you are frame 0 also before adding the spawn operator, because it will crash, it will spawn always. Let's connect this to the same output event, and let's see what we have. You can see now we get this nice boxy like movement. So I said that you don't want to use copy and instance, because particle flow will crash if you instance this spawn operator here. Not sure why, but I think it's because it's treating the particles operator instances differently, and holding it's holding some information about the particles. So if you go from one event directly to another instance, it may crash. But in order to fix this, if you still want to use the instance or copy, you need to basically to rest them in an event and then send them out to this event, so like a proxy event to use. So that's it will reset the operator states. So I will show you. So send out, connect this one here, like so, and we'll use the same spawn, hold shift, drag it here, instance, like so. Now everything will change here, will be reflected here and inverse. So connect this here, like so, and now we can connect to this send operator. So yes, just in case you will have crashed to know this problem. I'll not show how Max will crash, because I don't think it's a good idea. Okay, so what next? Next, let's export a frame to see how it will look with Krakatoa. Let's render this to see what we have now. Something like this. So, not bad. So I want to export the same frame 15, because you have nice a nice shape here. So this is why I've used the 15 offset in the magma flow. I told you earlier in the first part that I'll tell you later why I've used the 50 frame. This is because I've added later this animation, this movement, so it has a nice looking shape at frame 15. You can go higher if you want, but you'll need to change the offsets also. So go to F10, rendering, open Krakatoa, save particles. Let's set it to strand 1, like so, because we're using the event 1, this one. You can also use some age tasting, like here, so copy and connect this here. So let's now export the strand 1, one frame, single frame, frame 15, make sure, and let's now save particles. Okay, yes. Render, active time range, or let's leave it for now. I want to show you how it will look, just not to confuse you. So disable particle source, and now we'll unhide all. So I want to save this. Don't forget to save very often. So and now you should have, okay, you see now we have everything looks okay. Now I don't think our multiplier will grow enough to see everything. Let's see. Oops. Now let's change the multiplier. Go to magma flow. I'll select for now just this strand, the magma flow, like so, and let's change the multiplier to 100. Let's see what we have now. F10, render, yes. Show me some pic. Okay, so now we see that it's those movement are appearing. Okay, everything is looking good. Now we almost end the second technique of doing this animation. You know how to make our shapes, you know how to make our colors, you know you can animate the material, the noise, by animating, for example, this phrase. So let's, for example, put auto key. So auto key, go to frame 100, change phrase to 5. Not a very big, because we want to have some stability, not just random colors, because random colors is easy, but we want to do it hard way to look better. So let's see. Okay, it's changing. I want to see one thing. Okay, so one sec. I see. I didn't put the second material to be explicit map channel. This one, you see, this noise is not an explicit map channel. So we saw some world space noise. So now we can see that she's using color per strand. Okay, I don't like those colors. Let's see, I have red here and green and yellow. Let's set this to blue. 1, 2, hue size 0.1, like so. Okay, now it's better. Let's zoom out. Okay, now I like it better. Now you can use any map you want. You can use a blend, an animate wedge blend. You can use to make a video from colors from video, any generator of image you want. Okay, so now we want this is where I stopped when I was testing this technique, but we can go further. Let's maybe stylize the look of the particles a little more. So from now on I'll gonna experiment, so expect some problems to appear. And okay, let's do it. Let me save it before resume. So what we have now, let's analyze our particle information. We have texture coordinates, but I don't think we'll need, because I think we'll use world space textures. And let's say we want to blend the colors. Okay, let's first make a light. Standard Omni, and put it at the start, like so. Okay, and go to Krakatoa. Before moving on, I'm gonna save video, just to not have some crashes and other things. 1 second. Okay, I'm back. Let's see, open Krakatoa graphic user interface. Let's remove force additive mode. We see now that we have a different shading, and let me see if I can find a frame where it's very open. So this is frame 7, or maybe 15 should be good. So let's see, 15. So no, higher. Okay, now let's set it to 17. I like it. Okay, now you see the light is getting darker very quick. If you like it, you can leave it like so. One thing I also forget to show you how to use the velocity channel. This was also prepared. So let's do this first, then we'll play with the particle look. Okay, I'm gonna increase a little bit the particles density, like so. See, and because I started to talk about this, if you want these shadows to have a longer fall off, you can set in Krakatoa to use lighting path filter in density shadow in shadow group. Press use, and it will use this density settings only for shadow fall off, shadow penetration. So we want to make it think that the particle has a lower density for shadows. So now it will have more lighting. So if we have a bigger density, like so, have this look. Okay, you can also use lighting range, like density, color, attenuation, far range, like use show, maybe increase this a little bit, like so. Use some fall off. You can play it as you want. You may also use another. Duplicate this, light, copy, maybe like so. Change to another color. Reddish, maybe. No. maybe desaturated colors. I use very very saturated colors on particles, and you don't see very much of the lights, so use instead a little less saturated to have more variation in colors. Okay, so let's move on. I want to show you how to use the velocity channel. So let's use for now this one, this PRT loader in the center. Open magma flow, and we're gonna create new channel. Create nodes. Create output node, and we'll use velocity. Before showing you 1 second, the velocity, skipped it. Velocity, where are you? Velocity. Okay, so let's disable it for now. Let's enable motion blur and see what we have at this stage. Let's set this to 3, jitter and F9. So you can see we don't have very interesting stuff happening because our velocity multiplier is 0.001, which we've set in particle flow here. You can see, but we want to have the ability maybe to animate it, maybe to control it in magma flow. So let's add an input channel like so, and I want to use a velocity channel, so read the velocity like so, and then I want to multiply this. So let's add a multiply, arithmetic multiply like so, and let's multiply this by this value 1000. We'll connect it through the output, and by overwriting velocity, the Krakatoa rendering will use the new velocity to calculate the motion blur. Let's see, maybe a bigger value. Make sure which PRT loader has keep velocity channel. Yes, it has. Also, let me see Krakatoa launch particle data view utility. I want to see, so PRT loader 001, yes, and date. See it, if it has velocity. It has velocity. Yes, it's multiplied. And close this. Go back to magma. Open. Maybe bigger. We should start to see some lines coming out, but we don't see them. Maybe let's change this to okay, we see it, but it's hard to see because it's interpolating out. Let's set it to additive mode. Maybe it will be more visible. No, bigger density. Okay, now maybe or particle segments. See, see this value. Okay, it needs to be higher. Now you start to see this interesting velocity blur that's happening. So you can do many things with it, like connect it to the sound and make it like spawn with velocity lines, motion blur lines, our stuff. So to do this you can use the same technique by using input object, or you can animate it. I'll not go in details because I think it's clear how to connect an external value to an internal calculation. So I have this right value. Now one more thing I want to show you. If we'll not use the velocity channel, but we'll use a noise. So let's see, function noise, sorry, back noise. Let's remove this, delete function back noise, and we connect this instead of velocity channel. Let's see what we have now. Nothing good. Okay, the problem was that it needs input to have for evolution. So we'll use the input channel position. We'll use a position to have a different, let's say, seed, but I don't think it's the correct word. Okay, so let's disable normalize, because we don't care. We have a multiplier. Let's see what you have now. Okay, the multiplier is very big for vector noise. So let's set this to 1 for now. See what we have. Nothing interesting. 10. Nothing interesting. 100. Okay, we start to have some. We can put some normalize if you want, but anyway, okay, let's multiply it more and more. Okay, so you see now we have this nice kind of blurrish thing around, like so. And also you can animate it with sound and get some blur sound. Also you can use less segments, maybe shutter degree less, and let's remove jitter for a little bit to have more organized motion blur, and play with the values and see watch something creative. Okay, maybe a little less. Nice. Okay, so you can use this value for animating with sounds and other stuff. Now I'll show you how to connect it to a different frequency, how to make a different shape, how to make different colors, how to use textures. And now let's go back to particle look. I'll disable for now motion blur, like so. We have this nice lines. You can increase also the particle count if you want. Open magma flow editor, and let's go back to our shading mode. Remove force additive mode. Okay, so why I'm getting to normal mode out of additive mode? Because additive mode has a hack. You can see if you put the cursor on top, you can see that additive rendering by internal copying the color channel through the emission channel while setting the color and absorption to black. What this means? That is messing up the channels that we want to control. You can also use the additive to create our own additive mode if we want, by doing the same exactly the same thing that it's writed here. To use emission absorption, we need to enable them. So use emission. We're gonna use emission if we'll make some shine on the particles. So in order to make some shine, we'll enable the emission. We'll use a noise map. So let's create an output node. Okay, I don't want the position input. By pressing shift and clicking on the input, you can remove it. I want emission. You can see that it's flat free. I want a texture map input, so input texture map, input text map, like so. Connect it, and let's go through our mapping. Okay, create a texture, or let's duplicate this, rename this to shine map. Let's set this to black, this to white. So I'll repeat again that this is I'm doing live as I am recording. I didn't test it before. We want to use an object x, y, z, or you can set this to world. Let's set this to world. 10, increase the size, maybe like so. Let's see what we have now. Let's add the texture map, scene, materials, and see if we have shine map. Okay, instance. So we have this nice done material nice spots, let's say, on our lines. So we want to adjust it more. Let's set it to, I want to deal it a little bit in Z. I don't think it will work. Let's set it to object. 1 second. Okay, or it may work also in world space. Why not? Because okay, let's make a big tiling like so. Nice. Now we want to make a smaller, maybe not too small, but reasonable amount. Bigger interval, not so big contrast. Sorry. So let's decrease. Sorry, my phone. Let's decrease the contrast. See what we have now. It's too low. 4, 7, maybe fractal. Yeah, so let's increase this more. I want less white, more black, something like this. Okay, so this looks much better. So of course you want to animate it like face by going into auto key mode, like so. Auto key face 5, and also you want to connect it to a blend, like say function blend, connect this value 1 and a constant true value 2. Come on, why don't want to connect. Doesn't matter, we can create it like so. Input vector. Okay, set it to black, and the blending amount you can connect it to an audio or something else animated by hand. So this is the value we want to animate, and connect the blend to emission channel. F9. Okay, one more thing I don't like is I think when it's not even it's out of range, it's getting highlighted. So it's not depending on density so much. We want to multiply this by density. So go to magma like so, and we want to multiply this value by density. So this is our density, final density. We want to add another multiply node, arithmetic multiply, and let's connect the blend output with density. Now it may overborn this, so I want to multiply to normalize the density before connecting it to this one. So let's add another multiply just to be sure so everything is okay. Okay, multiply like so, connect switch like so. Okay, so now let's connect output. Now it's multiplied by 1, but we'll adjust this. Let's see, 9. Okay, looks better. Let's go to frame 17. What we have here. Okay, now it's looking much better. What next? Let's increase a little bit the multiplication, density, like so, or maybe it was okay. Increase it maybe like so. If we render now, you see some nice animation. You see that this will be animated also. What you can do more, you can play. Don't forget you have access to age, you have access to texture coordinates, so that is individual to each line. This is important. You also have many other things that you can blend different materials, different shading modes. Use it as you like, whichever you want, you have in your mind. What else? Okay, one more thing I want to show you, how you can, another way to generate the particles. So now I've used the backward generation, so we have the parents generating on the path and letting a trail behind, but you can also make it reverse. You can generate particles and move it up, so we'll have the age, the last particles will have a bigger age than the first one, but in this case the first particles have a bigger age than the last ones. So let me show you how. So save, file, reset. Yes. So let me particle flow, standard flow, birth. Okay, in this case we don't want to birth a stream. We want to birth a stream and not to shoot the particles at frame 0, so we can set this emit stop at frame 30. It's okay. You can change this. It will be the same frame that we'll use for our age animation. Amount, it will be a big amount. Position icon, let's use icon for now. You know how to use objects, so distinct points, chain points. Let's draw a line, all standard, like so. Have a nice line. So speed by icon, like so. Select icon, where is it? So animation constraint, path constraint, like so. Let's move it to frame 30, like so. Acceleration limit very big. I don't need rotation, I don't need cubes. Okay, we want a big amount of particles, we want dots, like so. Let's be bigger. So we see now have the same thing, except the age is now reversed. Oops, sorry. So same thing, except the particles are birthed from here and they are going all the way to here. Also, they're not distributed so evenly, so you can use it as another artistical mode. What else? If you color them, you don't need to subtract it from a value like I did in previous technique, like from 50. You can just use particle age directly and limit the maximum age. So connect to an input, audio input. If you'll have some question, you can ask it and I'll answer it. If you will have some difficulties with this technique, maybe you didn't understand, maybe you don't know how to apply, I'll not show you one more time because I will repeat myself and many people don't like this. Okay, so also you see that the ends are more randomly distributed. So yeah, you'll figure out how to color them by age, like the previous technique, but only in a different direction. Maybe this is better suited for you. Now if you want to use, for example, shapes and display geometry, like so, and maybe like set this to 1, more particles, so we have now this kind of drone-like animation. I mean old drone, not the new one. The new one we use our kind of it also uses cubes, but anyway. So also don't forget that particle flow use to color the geometry uses the point colors, so it uses like vertex colors, so you can use a mapping, material static, dynamic, material static. Okay, icon is changed, like so, and use the mapping by particle age. So and set this, animate this to, let's say, auto key, U1, apply gradient, the same thing that we did previously, like gradient ramp. Where is gradient ramp? Change the colors, doesn't matter for now, for you it will matter. So like so, assign it to material slot, like so, instance, okay, it's set now to Krakatoa, change it to default scan line. Now we should have this kind of effect where you start one color and okay, also want this animation of the material U to be at frame 30. Don't know why it doesn't let me to drag it, so let's go to track view and okay, let's undo dragging and set this to frame 30 like so, 0 here. So now should have this gradient at the last frame. And what next? You can scale it by age. You can put a scale. So scale modifier, scale like so. So same by the right. So you can put it to absolute. Seen by particle age, and animate it also frame 30. So auto key. You can leave constraint proportion, but it will have some problems. I'll show you in a second. Like say, no, not scale variation. I want the scale factor. So see what you have now. Render. Okay, you see that she's growing up. We can play with the curve editor, show and track view, and make something interesting like so. Copy value, remove constraint proportion because it will make you problems. It will try to match up. Paste, copy, like so, and paste here. Okay, now let's see. We have our scale. Also the same technique you can use for rotation and anything you want. So rotation, like speed follow, and maybe by Z. So oops, sorry, show and track view. So use your imagination. That's all, I think. Okay, thank you. So I was thinking about this idea. If you saw some effects in some movies, or you're interested in, you saw some interesting effects that you may want to know how they was done and can't figure it out, you can post a message on a comment on one of my video, and I'll try to figure it out for you and maybe make a tutorial. So I don't promise this, but let's try it. I want to experiment. Okay, so thank you and goodbye.